So we have x as a given expression of trig ratio of sine and just purely sine. But the one tricky thing here is one of the sine is 3 theta. And similar with y, it's got a 3 theta and a theta. So this tells me, like, to solve this question, we need to simplify this 3 theta. So let me make an attempt to simplify this expression. So x. So to first, trying to express the 3 theta in terms of theta, the first step will be split it up into 2 theta plus a theta. Now I'm going to use a compounded angle formula. So you get a sine of 2 theta, a cosine of theta, plus cosine of 2 theta, and a sine of theta. Okay. So we have 3 sine of theta minus, I'm going to expand that using double angle formula, a 2 sine of theta, cosine of theta, another cosine of theta, again a minus. I'm not going to expand that yet because there's 3 choices for this one. I'm not sure which one I have to take. So for that reason, I'm just going to leave it for now and pick one of the 3 choices when it becomes a little bit more clear. Okay, so now we have some common factors: sine of theta, and sine of theta. Okay, so we can factor out a sine of theta. Okay, so we have 3 minus 2 cosine squared theta, and then a minus a cosine of 2 theta. Okay, so now the cosine of 2 theta, to me, now I can pick the 2 cosine squared theta minus 1 choice because of the fact that there's a cosine here. Right? So if I pick this one, I have a chance to simplify this, right? So I get 3 minus 2 minus another 2 and a plus 1. So we get a 4 minus a 4 cosine squared theta. And we can factor out the 4. So you get sine theta and a 1 minus cosine squared theta, and that will turn into a sine squared theta. So we get 4 sine cubic theta. Okay, so that's quite nice, particularly because eventually I have to raise x to the power of 2 over 3, and I have a power of 3 here. So I know I'm on the right track, and I have to do this for y as well. Okay, so let me slide over here. Okay, so the first step is to split the 3 theta into 2 theta plus theta. Okay, so we have a cosine of 2 theta, a cosine of theta, minus sine of 2 theta and sine of theta plus 3 of cosine of theta. Okay, so I can see that if I stop and scan and see what they have in common. They have a cosine theta in common for the first and last, but they don't have that in the middle. But if I recall the double angle formula for sine of 2 theta, right, you know there is actually a cosine of theta in there. Okay, so let's factor out the cosine, a cosine, and cosine. And we get a cosine of theta, cosine of 2 theta minus 2 sine squared theta plus 3. Now, for the cosine of 2 theta, it's clear that I should pick this one. So I can combine it with this one. So I can add the 1 and 3, and I get 4. Factor out the 4, you get a cosine of theta, and 1 minus sine squared theta is cosine squared theta. So we have a 4 times cosine cubic theta. So now we're in a very good position to show that this is actually equal to 4 to the power of 2 over 3. So now we have x to the power of 2 over 3, y to the power of 2 over 3. Now our job is to show that this is actually equal to 4 to the power of 2 over 3. So let's replace x with this. So you have 4 sine cubic theta to the power of 2 over 3. Y is 4 cosine cubic theta to the power of 2 over 3. So we get 4 to the power of 2 over 3. Sine this cubic times by 2 over 3 gives you squared. 4 to the power of 2 over 3. Cosine cubic times by 2 over 3 gives you again a squared. And we can factor this out. When you factor that out, look what we end up in the bracket. We get exactly 1, and we're done showing that it's equal to 4 to the power of 2 over 3.